where a blowpipe blasts it with a stream of air and forms a hollow, continuous tube. This tube then solidifies as it cools and drops down almost 20 feet to the draw lines. Believe it or not, you're looking at a single continuous tube of glass.
You can see the tubes coming down and it's still red hot. So the first thing it hits is this air suspension conveyor. It's blowing air in and supporting the tube on that cushion of air, just like an air hockey table. There's about 12 miles of tube flowing past us here every hour.
As the tube travels the length of a football field, the temperature of the glass drops by over 1,000 degrees to just over 600 degrees Fahrenheit. So how do they cut this still scorching hot tube into individual tubes without shattering the glass? With this.
This machine is cutting the tube to their rough length, and it doesn't even use a blade. Instead, it's using a crack-off stone cooled with water. It just barely touches the tube, and the temperature difference between the cold stone and the hot glass causes a thermal shock, making the glass contract and break.
These tubes still need to be cut to a uniform size. So they spin over a ribbon of fire to heat the ends. Then a wet ceramic wheel delivers a clean cut to the end of each ball. It works the same way as the crack-off stone. The temperature difference between the heated tube and the cool stone cuts the glass. Another set of flames prepares the tube's ends for the next step.
This is called the end forming machine, and it does just what you'd expect. It forms the ends on the tube.
This machine uses heat to round and narrow the ends of the tube to form what are known as shoulders. Once the ends are formed, the tubes are ready to become the bulbs of our fluorescent lamps. Here are three other parts that will make up the lamp: the chemical coating that lines the interior surface of the glass bulb, the mounts placed at both ends of the bulb. They hold the electrodes that bring electricity through the lamp, and the mercury vapor, which interacts with the electricity to produce light. But before they can assemble the lamps, the bulbs need to go through the coating line. Here, a conveyor chain slowly raises them to a vertical position. Once the tubes are upright, nozzles rinse the dust and dirt from the inside surface. Another machine then coats the insides of the bulbs with two different chemicals. The first one seals the glass and dries to a clear finish. Then the second chemical, a liquid suspension of phosphor particles, coats the inside of the bulb. This phosphor coating is what produces the lamp's light. So how does the bulb light up? When electricity flows from one end of the bulb to the other, electrons excite vaporized mercury atoms. As these atoms calm down, they give off energy. But this energy is in the form of ultraviolet radiation, which is invisible to the naked eye. So something has to help us see the light. That's where the phosphor coating comes in. The phosphor atoms absorb the ultraviolet energy and re-emit it as visible light. They also give the bulbs their white color. But the coating isn't just phosphor. It also contains a lacquer that helps phosphor stick to the glass. So once the phosphor adheres, it's critical to get that lacquer out. That happens in this machine.
This is the Lear. It's heating the bulbs up to 1100 degrees Fahrenheit to burn off the lacquer in the phosphorus coating. Here's why. If lacquer molecules got in there and polluted the environment, you wouldn't be able to produce any light.
While the Lear heats the glass tubes, just a few feet away, another machine makes one of the bulb's most important components, the mount.
But what is a mount? It's really the electrical core that drives a fluorescent bulb.
The electrical core is held in place by a funnel-shaped piece of glass called the flare. At the head of the flare is a glass capsule filled with mercury. Once machines seal the bulb, the glass capsule will break, releasing mercury vapor. Two metal wires called lead wires connect the electrodes inside the tube to the power source outside. This allows electricity to flow through the lamp, powering the process that produces ultraviolet light. The phosphor then converts the ultraviolet light to visible light. To make the flare, miniature burners blast a half-inch piece of glass with heat. Then, two metal pins are inserted into the glass and spun outward to form a funnel. Once the flare cools, it's delivered to a stem machine, where mechanical arms pick up the lead wires and drop them into the flare. Then the sealing machine mounts the wires in the glass. But the most important part of the mount is this capsule, which contains 1.7 milligrams of mercury. That's less than a pinpoint.
Can you even see this? This tiny capsule is all you need to light up a fluorescent bulb.
Here, a machine attaches the tiny mercury capsule to the mount. Once they place the capsule, they then need to seal the bulb and mount together.
Here we've got the sealer and the pumper. The sealer is adding the mount to the end of the tube and melting it on.
This will keep the electrical wiring stable inside the bulb. Mechanical arms grab the freshly sealed bulbs and hand them off to the pumper. The pumper carefully pumps all the air out of the bulb and fills it with argon gas, or a gas mixture of argon and krypton. Finally, machines cap the bulb's ends with metal bases. At this point, it looks like these bulbs are finished, but they're not. First, they'll have to break something. And now that the folks at Philips have applied the right chemical coatings and have the electrical connections to deliver power, these glass bulbs need one last thing to become lamps. In this final step, they break the mercury capsules, making the lamps ready to start producing light. Philips tests every single lamp they make here. Each lamp is ignited with a high voltage that sends electricity through it and makes sure it lights up properly.
This looks like the world's biggest tanning bed. Are these ready for the customer now?
Yes, they are, Marshall. But I don't know if you noticed, but not a single human hand has touched these lamps in the entire process.
So the customer is the first one?
That's correct. Well, except for that one.
It takes only 30 minutes to make each lamp, but they can stay lit for at least 5 years. The finished light bulbs are then stacked, packed, and shipped out the door.